All right, let's step into the cockpit. Today, we're doing a crucial pilot's briefing on one of aviation's greatest hazards, the thunderstorm. We're going to break down how they form, the dangers they pose, and most importantly, how you stay safe.
So let's dive right in with a key question. Before we can talk about avoiding them, we have to understand what it even takes for a thunderstorm to come to life. It all starts here.
Here's our flight plan for this explainer. We'll start with the basic recipe for a storm, then we'll follow its life from birth to decay. After that, we'll get into the different types, uncover the most serious hidden threats, and wrap it all up with the absolute must-know rules for avoidance.
Okay, first up, the absolute fundamentals. For a thunderstorm to even think about forming, the atmosphere needs 3 specific things to be present, all at the same time.
Think of it like baking a cake, seriously. You need a ton of water vapor, that's your flour. Then you need an unstable atmosphere, which is like your yeast, just ready to expand like crazy. And finally, you need a trigger, something to give it that initial push upwards. That's the heat from the oven that gets the whole thing rising. If you're missing even one of these, you get no storm. Simple as that. So, once we have our ingredients, what happens next? Well, we get to see the life story of an individual thunderstorm cell. And let me tell you, it's a surprisingly quick and violent life that unfolds in 3 very distinct stages. You know, what's wild is that the entire lifespan of one of these cells is often just an hour, maybe an hour and a half, from start to finish. It all begins with the growing stage, then it hits its absolute peak intensity in the mature stage, and finally, it just rains itself out in the dissipating stage. Now this is a really important slide because it shows you the exact moment a storm gets dangerous. See, in the growing stage, all the air is moving up. But the second you see rain start to fall, you know it's officially hit the mature stage. And that's critical because that falling rain creates powerful downdrafts. It's that chaotic mix of violent upcurrents and downdrafts at the same time that makes this stage the absolute most hazardous for any aircraft. So we know how they live and die, but what gets them started in the first place? Well, not all storms are born the same way. We actually classify them based on what trigger gave that moist, unstable air its initial kick to start rising. You've got a few different ways this can happen. Strong heat off the ground, cold air moving over warm water, or even air being forced up the side of a mountain. But the one that really gets a pilot's attention is that last one, frontal thunderstorms. These are caused by a fast-moving cold front that just violently shoves warm air upwards, and they often form a dangerous wall or a line of nasty, fast-moving, and extremely turbulent cells. Okay, this is where we get into the really serious stuff. Let's talk about the specific dangers pilots are trained to recognize and, more importantly, avoid at all costs. This is way, way more than just a bumpy ride. I mean, just look at this menu of hazards. You've got turbulence so severe it can literally overstress an airplane, hail the size of golf balls, and severe icing that can form in seconds. But one of the most insidious, sneaky, and downright deadly threats, especially when you're close to the ground, is a powerful downdraft called a microburst. So what is a microburst? It's this incredibly violent column of sinking air that slams into the ground and spreads out in every direction. What makes it so incredibly dangerous is how small and how quick it is. We're talking a lifespan of maybe 5 to 15 minutes. It's a sudden, invisible trap, especially during the most critical phases of flight, takeoff and landing.
Let's paint a picture. Imagine you're on final approach. First, you fly into the outflow from the microburst, which gives you a sudden headwind and a nice performance boost. Your plane feels great, but that's the trap, because next you fly right into the core, a powerful downdraft that shoves you towards the ground. And just as you're fighting that, you pop out the other side into a massive tailwind, which instantly kills your airspeed and your lift, right when you need them the most.
And it's the exact same deadly sequence on takeoff. You might get an amazing initial climb rate, feeling like a rocket, only to hit that crushing downdraft, followed immediately by that performance-robbing tailwind. And all of this happens while you're low to the ground with almost no room to recover. That's why scanning for clues of a microburst before you even start rolling is so critical. So how do you spot this invisible killer? Well, you're trained to look for these clues. These are your red flags, your early warning system. If you see virga, that's rain you can see falling, but it evaporates before it hits the ground, or a weird lowering or bubbly-looking cloud base, or a ring of dust getting kicked up on the ground, you have to assume a microburst is there. That is a clear, non-negotiable sign to stay on the ground or immediately go around. Okay, everything we've talked about so far, it all leads to this. This is the most important part of the entire briefing. The simple, direct, and totally non-negotiable rules for staying safe. The number one rule is simply avoid. Avoid, avoid, avoid. The time to make a decision about a storm is on the ground, in the briefing room, not when you're staring at a wall of black clouds. Give every single storm a wide berth. We're talking at least 20 nautical miles. And if you see a storm with tops punching up to 35,000 feet or higher, or one with vivid lightning, you treat it with extreme respect. And just as important are the don'ts. These are the mistakes you just can't afford to make. Don't even think about landing or taking off if a storm is nearby. And never, ever, ever fly under a thunderstorm, even if it looks clear on the other side. The turbulence is often worse right there. And don't be fooled, a small storm can be just as violent as a big one. And finally, if you are ever unlucky enough to find yourself inside one, your best bet is to fly straight through. Trying to turn back just puts more stress on the plane and keeps you in the danger zone longer. Look, at the end of the day, understanding the science behind a thunderstorm isn't just an academic exercise for a test. It's a fundamental part of a pilot's commitment to safety. It's all about turning this knowledge into decisive, life-saving action every single time you fly.